All right, ladies and gentlemen, boys and girls, welcome to another math video. Today we are going to be talking about those complex numbers that we talked about in the last video, but today we're going to be doing more stuff with them. Okay, today we're going to be doing a bunch of stuff with them. So, for starters, let's take a look at our little friend I. Okay, remember we defined I. We said that if we have the square root of -1, we were going to define that as being our number I. Okay? And that is our indicator that something is a complex number. If it has this I component to it, then it has an imaginary part. Okay? So we're going to take a look at this I. So let me, real quick, erase some stuff. Boop. So if we take a look at I, again, we defined that to be the square root of -1. So now, what happens if we were, say, to square I? Well, that would be the same thing as the square root of -1 squared. And if we want to make a square root go away, remember that we square it. So we can, this square and this square root can cancel each other out, and we get that I squared is just going to be 1. It's going to be -1. Okay? So then, if we take I cubed, well, that's just going to be the square root of -1 cubed. Or we just found that if you take I squared, it is -1. So remember that I cubed is I times I times I, which if we take a look and grab these first two i's, well, that's just going to be I squared times I. Okay? So then, if we take I squared, we just said that I squared was -1. So this is -1 times I, or just negative I. So if we have I cubed, we can just jump straight and say, well, I cubed is just the same thing as -I. Then, I to the fourth. Same idea. If we have I to the fourth, well, that's the same thing as I times I times I times I. If we take these first two and these second two, we get I squared times I squared. Why did you become a triangle? Nobody wanted you to be a triangle. Stop it. So then, I squared times I squared, well, that's going to be -1 times -1, which now is just +1. Cool? So then, let's do one more step. I to the fifth. Whoops. I to the fifth power. Well, that's going to be I to the fourth times I, which is just going to be 1 times I, which we can simplify and just say is I. So, I to the first power is going to be I to the second power, -1, I to the third power, -I to the fourth power, -1, I to the fifth power, I. Okay, so that means that we can, now this pattern is starting over. Take a second and see if you can come up with what I to the sixth is going to be. Okay, hopefully you worked out that I to the sixth was going to be -1. -1. Try and figure out I to the seventh. Again, going to be +1. Or excuse me, I to the seventh is going to be -I. Whoopsie daisies. I to the eighth. Take a second, figure it out. It's going to be just 1 again. Okay? So, we see that I squared, I cubed, I to the fourth, I to the fifth, I to the sixth, I to the seventh. I apologize if that made a loud noise. I to the eighth, I to the ninth, I to the 10th, I to the 11th, I to the 12th, dot, 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 dot. Okay, so we can take this and say, all right, no matter what exponent we have for I, we can boil it down to either just I, -1, -I, or +1. Okay, it's just going to keep going in this same cycle. Okay, The easiest way that I've found to figure this pattern out is if we take and divide each of these by 4. So I'm going to erase the little proof that we did over here and say, okay, if I take I if I take I, come on, stay with me, computer. If I take I and say I take I to the third power, if I take 3 divided by 4, well, that's going to be 0, but my remainder is going to be 3. So we have a remainder of 3. So what if we did I to the 7th? Remember, these two things are the same. If we take 7, which is our exponent, divided by 4, since we have 4 things here that are repeating in that pattern, if we take 7 divided by 4, we're going to get 1, remainder 3. Take a look. We got that third remainder. What about I to the 11th? If we take 11 divided by 4, we get 2, remainder 3. So on and so forth. Whenever we get a remainder of 3, our value for that particular I number is going to be negative I. So if we say, all right, if we get a remainder of 1, we get positive I. If we get a remainder of 2, we get negative 1. If we get a remainder of 3, we get negative I. And if we get a remainder of 0, this is kind of hopefully might be a little counterintuitive, but if we get a remainder of 0, we get the number 1. Okay? And hopefully you can sort of see that out. Or let's do an example of that. All right? So let's say we have I to the 34th power. Okay? I to the 34th. If we take 34 divided by 4, this is going to be 0. And then, so 4 divides into 34 8 times. 8 times 4 is 32. 34 minus 32 is 2. So we have 8 remainder 2. Okay? So our expectation is that we should have I be negative 1, or I to the 34 should be negative 1, which hopefully is okay. Because if we say I times I times I, 4, 6, 7. Believe it or not, there's 34 I's there. I didn't feel like making you watch me draw all of them. So believe it or not, there's 34 I's here. And if we group them in 4s, well, we said earlier that I to the 4th power was 1. So we have 1 times 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 1, which leaves these two guys off on the end, which is I squared. And we said that I squared was equal to negative 1. So we can evaluate I to the 34th as being negative 1. Okay? So we can do this with any value of any exponent of I. Just divide it by 4. Whatever your remainder is, it will whatever your remainder is, as long as it lines up with one of these, whatever your remainder is will tell you the actual value of that number. Okay? So, first operations that we're going to do with complex numbers are adding and subtracting. And this is going to be way easier than you might think. Okay? So remember that all of our complex numbers are going to be written of this form, a plus bi. Well, try and think of it like this. What if we had 3 plus 4x plus 2 minus 6x? How would you add those two things together? Say we had this guy plus this guy. Go ahead, take a second, add those two together. All right. Hopefully you remembered that when you combine terms like this, you're always looking to combine like terms. All right. So if we take the 3 and the 2, we have 5. 4 plus negative 6 is negative 2x's. 4 plus 4x's plus 6x plus negative 6x's is negative 2x's. And this would be the simplification, the addition problem for these just binomials that we were adding together. So we're going to do the same thing when it comes to adding and subtracting complex numbers. So let's say we take the number a, or let's not do a. Let's do negative 3 plus 4i plus, so we have, this is one of our numbers, plus, let's do negative 5 minus 2i. Something like that. All right? Take a second, see what you can come up with on your own. So hopefully you came up with negative 8, negative 3 plus negative 5 gives you negative 8. 4i minus 2i, or plus negative 2i, gives you positive 2i. So hopefully you came up with 8 plus 2i. Okay? Same idea for subtraction. All right? Same idea for subtraction. So let's take a look at the equation. 4 minus I minus 5 plus 8i. Okay? Take a look at that equation. 4 minus I minus 5 plus 8i. All right? So here, what we do, same idea for subtracting. Actually, you know what? Pause the video, see what you come up with. All right, hopefully you came up with negative 1 minus 9i. If we took 4 minus 5, 4 minus 5 gives us negative 1. If we take negative I and then subtract 8 positive i's from it, so we take negative 1i minus 8 more i's, we get negative 9 i's. So when you're subtracting, just be really careful that because you're going to have to distribute that minus sign into the parentheses. So if you wanted a little intermediate step, it can sometimes help to say, all right, I'm going to take 4 minus I. Since I'm not doing anything to that, we can actually get rid of the parentheses. 4 minus I. But since we are distributing that negative, negative 1 times 5 is going to be negative 5. Negative 1 times negative 8 is going to be negative 8i. So now we have 4 minus 5, which gives us negative 1. Negative I minus 8 more i's give us negative 9 i's. A couple of ways to think about it, but feel free to do whatever feels comfortable for you. Subtraction has not changed. Okay, it's still the same subtraction you've been doing. So hopefully, since you saw that adding and subtracting were pretty much the same thing we've been doing, hopefully you'll identify that multiplying is also going to be pretty much the same thing. All right, so let's try multiplying. Let's say we multiply these two together. Parentheses, 5 minus 6i times 4 minus 3i. Pause the video, see what you come up with for this. Just do all the normal distribution stuff and see what you come up with for this multiplication problem. All right, hopefully you're able to get here. By distributing, 5 times 4 gave us 20. 5 times negative 3i gave us negative 15i. Negative 6i times 4 gave us negative 24i. And then 5 times negative 3, 5, ooh, whoopsie daisies. That's embarrassing. Go away, please. Go away, please. Negative 6i times negative 3i is not 5i. Not sure why I wrote that down, but 18. Negative 6i times negative 3i is positive 18i squared. So then, when we combine like terms, we have 20 by itself, negative 15 i's minus 24 more i's gives us negative 39 i's plus 18i squareds. Okay? So from here, we take and we want to, we would normally be done if we were just working with variables. Okay? But remember earlier, what did we say that I squared was going to equal? I squared equals what value? Well, it equals negative 1. So this is going to be 20 minus 39i plus 18 times negative 1, which is our value from I squared. So this is essentially going to change the sign on the 18. Everything else is going to stay the same. That stays 20, doesn't become 18, minus 39i. But now we have this guy here and this guy here, so we should end up with 2 minus 39i. Okay? So remember our form of a complex number. Our complex number can have a plus bi. So whenever we're multiplying numbers together, we want to get something of the form a plus b times I. Okay? We want to make sure that we don't end up with extra I squared weirdness or anything like that. All right, we can have just A's, we can have just BI's, but we don't want to have, there's no such thing as A plus BI plus CI squared plus DI cubed or anything like that. That's not a, yeah, not a thing that exists, which I understand that we are talking about imaginary numbers here, so things that exist are really kind of a questionable thing, but just for the universe of mathematics, you can have just real numbers, you can have just imaginary numbers, or if you have both of them, you get a complex number. Okay? So those are the operations that you're going to be doing with those. There's going to be one more video in today's little video series that I'm going to want you to take a look at. And so with that, I'm going to end this video. And you can feel free to work on parts of your homework that have to do with this, and then whatever, however you want to do that. But I have rambled long enough. See you guys. Talk to you later. Bye.